Welcome back. Remember in the past when we were talking about the homologous series, one of them has these functional groups OH, if you remember. So the homologous series with the functional group OH are alcohol, and that OH group is called the hydroxyl. So let's look at the first family members of this homologous series. So remember, before we look at those first family member, we need to look at the general molecular formula for the alcohol, which is CnH2n plus 1 OH. So we can use this to generate the formula of the first four family members. So the first member that we want to look at is when n equals to 1, that is the first member. So if n equals 1, so it means C is C1, then H2 times 1, 2 plus 1, that's 3. That's CH3OH, methanol. And the displaced formula for methanol is carbon 3 hydrogen atoms and then OH. So this is the displaced formula for methanol. So the next member is when n equals 2. So if n equals 2, we're going to have C2H5OH. And the display formula for this is CH3. So we have C2 already, H3, and then plus this making H5, then OH. So this is because we have two carbon atoms, so that is ethanol. So remember, all is because of this OH. So that's why the name ends with all. That OH is the functional group. Don't forget. So the third family member we're going to look at is C3H7OH. Just add another CH2 to it. Remember when we're talking about homologous series. So we can just pick this CH2. So we have our propanol. We cannot just say propanol because we need to look at where the functional group is attaching to. Which carbon is it attaching to? So when we have three carbons upward, we need to indicate the location of the functional group. So this is carbon number 1, carbon number 2, carbon number 3. So you will need to number it the other way around. So to check whether this 3 is correct or not. So it's carbon number 1 again, number 2, number 3. So remember we have this carbon is number 3 and also number 1. So we take the list of the two numbers. So we are going to take carbon number 1. So that is this carbon, the OH is attached to carbon that is labeled number 1 and number 3. So number 1 is smaller than 3, so we are taking 1. This compound has to be propan for 3 carbon atoms, 1 all, that is our all, the OH is attached to carbon number 1. So let's take one more family. We can just carry this and then we paste it here. So we adjust it. We remove the OH and then we add a new CH2. So we have it here. And then the OH, let me remove this number. So let's bring in the OH. So this is butane. The all is also attaching to carbon number 1. So it is butane 1 all. So, and then it is going to be C for H what? Should be H9 and then OH. So these are the first four family members of the alcohol. So if you compare the number of carbon atoms for each one, this one has 1 carbon atom, 2 carbon atoms, 3 carbon atoms, and 4 carbon atoms. So it means the chain length is increasing from left to right. So if chain length is increasing from left to right, so definitely the boiling point will be changing as well. So this one will have the lowest boiling point, which is 65 degrees centigrade. And this, that is butane 1 oil, will have the highest boiling point, which is 117 degrees centigrade. Of course, ethanol is 78 degrees centigrade, and then propane 1 oil is 87 degrees centigrade. You can see how the boiling point increases from the smallest member to the member number 4 here. So let's quickly look at structural isomers in alkyl as well. Or when I say alkanol, remember I mean alcohols. So this is propan 1 ol. We call this one propan 1 ol because the ol, that is the OH, is attached to carbon number 1, as we said earlier, 1, 2, 3. So let's look at this. When we change the position of that OH, we have carbon number 1, carbon number 2, carbon number 3, and then we put OH on this carbon number 2, and then we supply all the hydrogen atoms. So this is also propan because there are 3 carbon atoms, but our all now is attached to carbon number 2, so it's going to be 2 all. So if we look at the structural formula, that is the display formula of both of them, they are different because the OH is on carbon number 2 here, but it is on carbon number 1 here. But if I want to write the molecular formula, I will still write C3H7OH. So they have the same molecular formula, but different structural arrangement. They are structural isomers. Propan 1 ol and propan 2 ol. So the same thing can work for butan 1 ol as well. Our butan 1 ol is this. If you remember, we have the OH on this first carbon atom. Remember, this OH can be here as well. So if the OH is here, this is the first carbon atom. So I put the OH at the left side now. This is butan 1 ol as we saw it last time. So let me copy this and then we'll paste it. So we'll put it here. So instead of the OH to be on carbon number 1, I will put hydrogen here. Then I will remove one hydrogen from here. So when I remove the hydrogen, I put the OH here. So when putting the OH here, if we number the carbon atom, this is carbon number 1, 2, it is number 1, number 2. So this is butan 1 ol, and this is butan 2 ol. Now, if you write the molecular formula for both of them, this is going to be C4H9OH, and this will also be C4H9OH. So they have the same molecular formula, but different structural arrangement due to the position of the functional groups. So therefore, they are structural isomers. Now, I have a challenge for you. Let us take this butan 2 ol again. I will just rewrite it quickly. What if I remove the OH from here, and I put hydrogen atom here, and I put the OH on the next carbon atom, which is here, like this. Let me number the carbon: number 1, number 2, number 3, number 4. So are we going to call this one butan 3 ol? Is this butan 3 ol? No, that is not butan 3 ol, because remember, you need to check. It is very important to check when you number it from right to left or from left to right. You have to number it back as well. This is 1, this is 2, this is 3, and this is 4. Now that the OH is on this carbon atom, are we going to choose 3 or we are going to choose 2? Remember, we are going to choose the smallest of the two numbers. So this is the same as what we have up here. Both of them are butan 2 ol because the OH is still on carbon number 2. So in the next part of the series, we will look at ethanol, one of the important member of this alcohol group.